Episode 22, the Other Ham Radio Podcast. Special guest host, special guest. Stay tuned. We're drilling holes, y'all.
AmateurRadio15.com presents Faux Time, the Other Ham Radio Podcast. Sponsored by Main Trading Company. Find them online at mtcradio.com. Now, here's your host, Cale Nelson, K4CDN.
It is episode 22 of the Faux Time Podcast, the Other Ham Radio Podcast. I'm Cale, your host. Thanks for tuning in. Got a great one coming up for you. Yeah, KF7IJZ Jeremy, our buddy here on the program, is going to be talking with a new friend of ours here, K0BG Allan, Applegate from Roswell, New Mexico. And that may not ring any bells for you until I tell you, if you visit his website, Kilo0BravoGolf.com, you'll learn all that you want to know about mobile amateur radio operations. It's a great interview, great call, and it's coming up in just a couple of minutes. But first, we got to give a shout out to our friends down at Main Trading Company in Paris, Texas. They are the official Faux Time, the Other Ham Radio Podcast show sponsor, and we want to say thank you to them, of course, for being here with us and offering you, our listeners, some really great deals. If you need some stuff, you should check them out. They not only have the latest and greatest, the brand new, still in the box, fresh from the factory, they also have a very large selection, a very grand selection of used and pre-owned gear. Richard goes back and forth to the Ham Fest. He's kind of a horse trader. If he's not listening, I guess I could say that about him, but he always brings in a lot of great gear. So if you're looking for something specific, they may even have it, or you can call them, get them on the lookout for it, but they will not disappoint you with their prices. Their service is out of this world as well. So make sure you check out the show sponsor at mtcradio.com. I've got an announcement coming up in the middle of the program about episode number 25. We haven't gotten there yet, of course, but we are approaching it. But first, I want to toss this over to Jeremy and bring in Allan with him so you guys enjoy this back in a few here on the Other Ham Radio Podcast.
All right, thank you, Cale. Folks, it's Jeremy, KF7IJZ, and today I have with me Allan Applegate, K0BG of K0BG.com fame. I first ran across Allan several years ago when I decided I wanted to try mobile HF, and intuitively I knew that mobile HF was likely to be a series of compromises, and I wanted to make sure I was doing everything I could to have as an efficient an installation as I could. And Allan's website was absolutely indispensable in providing good information. And he really is a very well-known and talked about resource in the community. Folks at HRO used to bring it up all the time. And it's readily apparent that more people need to know about this information, because you go to Dayton and you still see people do a lot of silly things with HF antennas, and we all know they could do better. So Allan, thank you very much for joining us today. And I have to ask, what got you going down the path of being passionate about helping people learn how to do the best they possibly can for mobile HF?
Well, that's a long story, and it's about 40 years in the making, so I don't know that I can remember all of it. However, in 1972, I took a job on the road traveling. And as a result of that, it was kind of nice having somebody ride with you, and not necessarily a partner or a boss or someone else, but about 450 watts out mobile. And back then it was almost unheard of to have an amplifier in your car. And I discovered forthwith that there were things that worked fine with 100 watts or maybe 150 watts if you were lucky enough to own a Swan, but things with 500 watts, that was a whole new ballgame. So it just kind of blossomed from there as I just traveled along and took various traveling jobs. And for a while, I was driving about 100,000 miles a year. So and through the Rocky Mountain area where there's a lot of snow. And so amateur radio was not only a companion for me, but it was a little bit of a safety feature. And if we sort of step forward of quite a number of years, after I moved to Roswell from Denver in 2001, I attended a ham fest over in Alamogordo, New Mexico. And there I noticed a car. It was a Subaru, and it had an Icon 706 mounted directly on top of the airbag in the steering wheel. And I thought to myself, boy, that is so wrong. So after I got home, I thought about it a little bit, and needing something to stay out of my wife's hair with, I decided to start a web page. And that web page went live on April the 27th of 2004. And currently it's pretty popular.
Yes, it is most certainly popular, just from talking to other hams that I know. One of the things that's amazing about the site is that you cover the subject of mobile HF operation from pretty much every angle. You provide information on radio mounting, you provide information about power, information about proper procedures for antenna mounting and different ways to do that. And you cover the entire gamut. Now, we have a lot of new hams who've written in. We did a survey a little while ago to see what people wanted to know about. And mobile HF operation was a really portable topic. So I wanted to have you come on today and kind of share with us, we'll say, your top 3 things that you wanted to make sure that every amateur or new amateur knows, before they go and just start taking a trucker's mag mount with 4 magnets and sticking, a couple of ham sticks up there. This is your opportunity to kind of set new hams on the right path of mobile operation. So what are your top 3 issues?
Well, pet peeves, among other things. And I think the top one, period, is that drilling a hole in sheet metal is not the end of the world. And what most people don't realize is that what the performance difference between, say, a clip, a lip, or a mag mount and a permanently mounted one where we mount it through a hole into sheet metal. And I installed the antenna on the car, and I worked 7 DX stations the first day. Well, the thing about DX has absolutely nothing to do with any antenna. It only proves that the band was open. And the excuses vary from it's my wife's car, it's a lease car, you name it. But to be very honest about it, I think it's the fear factor of doing something wrong because they've never done it before.
Yeah, that is, I've been in that situation myself also, about not wanting to drill holes, but it is something that I got over originally by installing a VHF, UHF antenna on one of my vehicles, and I've certainly helped a lot of other friends drill holes in their cars. And you're right, the performance difference is definitely noticeable.
Yes, and Jeremy, there's a couple of other things that are missed into this permanently mounting things. Every mobile, period, HF, and even VHF to some respects, there will always be common mode current. And as you know, a common mode current is the RF flowing back toward its source on the outside of the coax feed line. And that is the definition for common mode. And there will always be some in every HF mobile, no matter what. Now, this, if you please, of common mode is directly related to how much ground loss there is. So whatever you do to reduce ground loss, whether it be proper mounting, bonding, and all of the other things to decrease the amount of ground losses, also decreases the amount of common mode. Nonetheless, we need to properly choke it, but it's very difficult to choke high amounts of common mode current no matter what you do. And the highest, of course, is mag mounts with lip and clip being second. And the lowest, of course, is through hole mounts. But there's a lot more to correctly installing mobiles, and probably the second most important thing is wiring. And what do you suppose, Jeremy, that the biggest mistake neophyte amateurs use when they wire their amateur gear?
Well, I know that one of the mistakes I made was trying to use the smallest cables I could find.
That's part of it. And the biggest one is using vehicular wiring that's existing to power amateur gear. And you see quite often people using the cigarette lighter, or what is now called an accessory port. And they justify it because they say, well, it's a 15 amp fuse. I should be able to draw 15 amps. It's a large voltage drop, so the wire heats up. And over time, the wire can fail due to this continual heating process and having the insulation fail. And technically, it's called and for fire, like pyro. And it's not the thing you want to do. And in fact, all of the manufacturers, the big three, certainly Icon, Kenwood, and Yaesu, have all said in all of their manuals that you do not use existing wiring, that you wire directly to the battery. And while we're on this subject, newer cars who are equipped with battery monitoring systems typically have a Hall device mounted in the negative lead of the battery where it goes to chassis ground. And in those cars, the ground for the radio needs to go to the same chassis point as the battery ground and not to the battery directly. If you hook directly the ground to the battery, then you bypass the battery monitoring system, and that's something you do not want to do.
Well, that's something that's definitely good to know, because I didn't know cars were doing that. But I kind of want to ask you two questions. Let's go back to the common mode current real quickly, but for a new ham, they may not know what that is. Can you explain what common mode current is and why we don't want it?
Okay. In an ideal situation, let's digress just for a second. And remember that RF must return to its source. It's no different than a DC circuit that we hook up a light bulb to a battery. If there's no ground, guess what happens? The light doesn't light. And RF is the same way. It must return to its source. And in an ideal situation, the RF goes up the outside surface of the center conductor of the coax to its load. In this particular case is the antenna, and it returns back to its source on the inside of the surface of the shield. We have to understand that RF goes on the surface of wires and not through it like DC does. Now, if there is an imbalance at the antenna, for whatever reason that imbalance is there, then some of the return current flows over the outside of the coax cable on the shield itself, and that is by definition common mode. Now, we have a couple of things we can do to handle common mode. Obviously, proper mounting is the biggest issue, but even then there will be a slight amount. Now, so we can install a choke, and there's information on my website about how to properly wind one and what material, ferrite material, to use to wind the choke. Now, the question then remains, well, gee, what happens if we don't do that? Well, understand that common mode radiates. In other words, it becomes part of the antenna, the coax feed line that is, and it radiates inside your car and causes all sorts of RFI. Well, common mode is a two-way street. If the RF can get out, the RF can get in. So if you do not properly choke off the common mode, then all of the electronics inside of the vehicle itself go right on the outside of the coax, right back to the source. That's the radio in this case. So you also, not only do you interfere with everything inside of the car, but everything inside of the car interferes with you. So it's very important to properly mount and properly choke common mode.
Okay, that makes a lot of sense. Now, going back to using existing vehicle wiring, I know myself, I had the foresight to run a new lead from my battery into my car, but I was lucky because in my particular vehicle, there was an accessory grommet in the firewall on the passenger side that was designed to allow people to run cabling from the engine compartment into the passenger compartment, but a lot of cars today don't have that. So, what guidance can you give for a new ham who is trying to run electrical cabling into the passenger compartment, or maybe all the way back to the trunk or cargo area?
Well, the obvious answer, of course, is drill a hole. Almost all new cars, say made since 2010 or thereabouts, some even early as 1990, have an accessory port someplace in the firewall or on the main wiring harness for the exact reason that you found yours. Although it wasn't made for us amateur radio operators, it was made for aftermarket sound systems primarily. But it typically is there. There are a few cars that don't have it, and it may be necessary for you to drill a hole in the firewall to feed the power through. Now, again, this is sort of a fear factor. You obviously have to know what's on both sides of the firewall, and that fact stops a lot of people from doing that, hence they try to use vehicle wiring. The primary reason to run wiring direct to the battery and or the chassis, battery chassis ground is to minimize the voltage drop. Now, the rule of thumb is not more than a half volt drop at operating voltage. And let's digress just a minute and talk about that. A normal car battery in a normal automobile, depending on whether it's a flooded lead acid or perhaps an AGM, a couple of the new cars actually use lithium batteries, a few lithium iron, and a few other technologies where the base voltage without it being charged is more than 12.2. But if you notice in most of the manuals, the radios today, nominal 12-volt radios, are actually designed to operate plus or minus 15% from 13.8 volts. Now, if you drop the voltage too low, let's say down to the 12.2, and you talk on the radio, you drop a half a volt. A lot of radios, like an Icon 706 or a 7000, will just shut itself off if the voltage drops below about 11.7 or 11.6. So you don't want that to happen. So you need to adequately wire so that there's no voltage drop or minimal of about half a volt. Nominal car, when it's running, will run from 14 volts to about 14.7, 14.8 if it's cold outside. Most of them run around 14.2 when the engine is running. And as a result, the transceiver puts out full power. To give you an idea on a 7000, which I'm very familiar with since I've been running one for about 10 years, is if you drop the voltage to 12.2, the power output drops to about 50 watts. Now, the difference between 50 and 100 isn't much, but there's another little issue that comes into play. When the voltage starts dropping down and or the SWR gets a bit high, the third order intermodulation distortion, just commonly referred to as IMD, goes up, and sometimes very drastically. A couple of the radios that are no longer on the market, for instance, like the Yaesu FT100, you drop the voltage down to 12 and the IMD is about minus 20 rather than the spec, which is minus 43. And you can actually hear the distortion in the transmitted signal. And so it's very important to wire properly to minimize voltage drop no matter what you do. And that may require actually enlarging the size of the wire to the transceiver depending upon how far away from the battery it actually is. And I should point out that we don't care about the current carrying capacity of the wire, but what the voltage drop will be under full load.
Which, when you say full load, the average modern 100-watt HF radio is going to be about 22 amps. Is that the number that we use to size this, or do you use like an approximation if you're just doing sideband of 12 to 16 amps? What do you recommend?
Well, what I do is the maximum peak power. That's what you should consider, and not what the average current draw of the radio is, because the average current person's speech process or speech pattern, as it were, or what he uses speech compression, which they should never do mobile. We can touch on that, if you please. So in an Icon 706, 7000, 7100, 7200, that's 22 amps. In the case of a Yaesu, that's 21 amps. If we're talking about Kenwood, the HX high power version of it, it's about 45 amps. that it draws. In your case, which is a 480S, the SAT version with the automatic tuner built into it, that's about 21 amps or thereabouts at full key down power. And that's what you should be able to see. If the radio is rated, say at 100 watts output, you should see at least 100 watts into a dummy load with the engine running. If you don't, you can almost guarantee there's too much voltage drop.
Now, about voltage drop, because, as I do a lot of stuff with portable solar power and solar ham stuff, and this is something we've talked about. I've talked about on my YouTube channel quite a bit, is, voltage drop in the cabling. And there are a lot of good calculators online, and I will make sure we put in the show notes, a link to one or two that allow you to basically put in the run of the cabling that you want in feet. You set the voltage at a nominal 12 volts, and then it will calculate the average voltage drop based on current. Folks, this is KF7IJZ with Allan, K0BG, owner of K0BG.com, a premier source for everything mobile HF operation. Stay tuned. We'll be right back.
Visit mtcradio.com today, a great one-stop mom-and-pop shop for everything ham radio. Radios, antennas, power supplies, wire and cable, books and training materials, microphones, headsets, and accessories. Find popular brands like MFJ, Heil Sound, Jetstream, LDG, Alinco, Comet, Texas Bugcatcher, Radio Waves, and more. mtcradio.com, an authorized Kenwood and ICOM dealer. mtcradio.com.
Real quick before we go back to Jeremy and Allan, just want to mention sign up this week for the email, okay? Sign up for the email. You're placing yourself into a very good position of winning something regarding the 25th episode of the Photime Podcast. It's going to be in just a couple of weeks, and we've got some folks, some of our previous guests on the program are coming back with some of their products. Sierra Radio Systems, Pignology, and others have already joined, and we're going to put this stuff in your hands, so make sure you qualify yourself by signing up over there on the left side of the amateurradio15.com website. Back to my boy Jeremy and Allan here on the podcast.
Folks, we're back with K0BG. We're talking about drilling holes in our cars for proper antenna installation, talking about using our own wire to get power to our radios, and some of the problems that happens if you don't do that. Allan, what else do you think we need to know?
Well, there's a couple of things. You mentioned going to online calculators, and there are quite a few of them, by the way, that you can tell what the actual voltage drop at any particular amperage drop or amperage load will be for a specific size wire. However, you have to keep a couple of things in mind. Number one, most of the online calculators are only for one wire, and we have to understand that we have the voltage drop not only through the positive wire, but we have a voltage drop through the negative wire as well. The other issue is that I do not know of any online calculators that include the voltage drop across the fuse and the fuse holder. Now, those are depends on the fuse, the type of fuse that we use. The calculation or the formula that's on my website in the wiring article does include the voltage drop across the fuse and the fuse holders, so that you can pretty well. And you say, well, gee, it's the voltage drop's only about 90 milliamps. Well, it could be a lot, 9 microamps, but it could be a lot more than that. It would just depend on the fuse, depend on the holder, and a lot of others. And there's just a rule of thumb there that you can use if you don't know what the voltage drop across the fuses it will be. And while we're on that, one thing to consider when you are fusing a mobile radio is most of them use what is called an ATC fuse. It's an automotive fuse. The C on the end actually stands for closed. There's also an ATO, which means it's open, and you don't want to use those because the fuse is not sealed. If you have it in a location where it might get water into it when you're washing the car, driving in the rain, or whatever the case may be, the rain can actually enter the fuse and cause the fuse to prematurely fail, which of course you don't want it to do. So you want to use the same type that came with the radio, and in that particular case, like ICOM, Yaesu, and Kenwood, is an ATO fuse. And almost nobody, or ATC, I'm sorry, closed fuse. Almost no one uses tubular fuses anymore, Jeremy.
Okay, that's certainly good to know. One of the things that, in talking about wire, pretty much every one of these mobile radios comes with what I'm guessing is either a 14 or a 12 gauge cable from the radio. And it's always been my impression that when you're running power in the vehicle, that's not really adequate, especially for the length that it comes with. And generally, I'm starting at about 10 gauge of cable. Do you agree with that? Have I been right on that?
Pretty well, but I can speak clearly of ICOM and Yaesu, but the wire is actually number 10 Japanese wire gauge, which is roughly equivalent to American wire gauge number 11. Although you can't really buy number 11 wire at all. It goes in the even sizes, as you're aware. If you take a standard 3 meter long, it's call it 10 feet, if you will. It's very close to 10 feet. And you put 14 volts into the end of it, and you put a 22 amp load on it, you will find out that the drop is actually very close to 0.6 volts. It's actually a little more than what it really should be. So it's okay, you'll be all right for the most part if you use just the factory wiring. But you used a situation a while ago, what about the trunk? Well, that's another 3 meters of wire. So number 10 isn't big enough, and number 8 is just barely adequate. But I like to go one size bigger. And if I wire to the trunk and all I have is just the radio, I'd wire with number 6. Again, not because I need to carry 60 amps of current, because I want to minimize the voltage drop to less than 0.5 volts.
Now, and you made a really good point earlier that a lot of us, and honestly myself included, because I haven't done this in a while, you're right, you have to double the length of your cable run. If you're only using 10 feet, you have to put 20 into those calculators because you have the loss on the positive side and the loss on the return for the negative side. This brings up another topic that has been, debated at least in my former club quite a bit. And that's, is it okay to take the Motorola approach to grounding of the radio by just taking the negative lead to a chassis point somewhere near the radio rather than running it back to the engine compartment?
I get asked that question a lot. And in fact, some online sources, incredible sources, that 25 years ago, but you don't get by with it now. Everybody seems to think that automobile manufacturers ground hither and yon. If they have a sensor, they ground it on the chassis wherever, and they run the positive wire back and be done with it. Well, that was fine 25 years ago, but you don't do that today. Because the digital signals from the sensor, and I'll give you a typical idea, a sensor that's in all modern automobiles, is a wheel speed sensor that's on every wheel in every car. If you use the chassis for a return, you run a chance of running what is called a ground loop. A ground loop is a differential between the potential between any two given points. And the one way to look at this, I spent a lot of time measuring the actual resistance between say a chassis connection in the radio and the trunk, and connecting directly to the battery in this particular case with copper wire. Well, the voltage drop through adequately sized copper wire was less than a half a volt, but if I used the chassis for the ground return, it was 1.5 volts. So it shouldn't be take a rocket scientist to figure out that there's more drop through steel than there is through copper. And you don't want to do a ground loop because you interfere with all of those sensors. And in fact, it is probably one of the biggest sources of RFI is to use the chassis for a ground return. That's something you just don't want to do. As I said, you could get by with it 25 years ago, but you can't do it today.
Well, that's really good to know, and I hope my friend Tim KT4MV is listening, because he's an old Motorola guy, and every one of his vehicles are grounded to a close chassis point. Now, in talking about those grounding things, and that's really interesting about the total loss in the copper. What have you seen, or what opinion do you have on the often debated, should you have a fuse holder both on the positive and the negative side? A lot of people say you shouldn't have one on the negative. Some people say, and of course the manufacturers put them on both sides, but where do you stand with that?
Okay, I'm going to give you a actual real case of having the fuse remain. Now, there's, again, a school of thought that if you use the chassis near the battery ground for return, then there does not have to be a fuse. Technically, that's true. However, there's another issue involved in this, and I will tell you exactly how I stumbled onto it. And in fact, there is an article coming up in the May QST that I wrote about this exact very subject. In this particular case, this was a Nissan Titan pickup truck. And the gentleman, like you, running a 480 SAT, installed it into the truck. And on my website are some pictures that you could look at to actually see where the battery is grounded to the frame of the vehicle. It's right there in the picture. You can see it, the screw. Then the cable runs on down to the starter. Well, in his infinite wisdom, he unscrewed that bolt and he put the chassis or the negative lead of the radio underneath there with a star washer between them to make sure he had very good contact. Smart move. And he tightened it back down and everything was fine. 2 weeks later, the MIL, which is the maintenance indicator light on the dash, lit up after he started the car. Well, what had happened is that screw, bolt, whatever you want to call it, broke. Now, why it broke is a matter of conjecture. It may have been over-tightened. It's hard to say why. But the negative lead of the radio was still connected to the ground running over to the starter motor on the car. Well, what happened is that then some of the current, rather than running through the chassis that it should have, ran through the radio ground itself, and it blew that negative fuse. Now, if that negative fuse had not been there, then there surely would have been damage to the radio. Yes, it's a rare occurrence, very rare, but still nonetheless it occurred. And it can occur with any radio. It doesn't have to be a Kenwood or an ICOM or anybody else. Now, someone could argue, said, well, they should have bolted it through a separate bolt. Perhaps true, but there's one. And I, being the perfectionist that I am, if you remove the fuse in the negative lead, you also create a ground loop so that there is less loss connection than there is through the positive connection. Now, that may or may not cause you any problems depending on how the antenna is mounted. Again, understand that if we properly mount an antenna, then the chassis will also, or the return ground through the coax shield will be at the antenna connection point as well. Now, you can say, oh, well, it doesn't make any difference. Well, it does make a little bit of difference in ground loop wise. Now, could it cause a problem? Well, maybe, maybe not, and it's an arguable point. But why ask for it? Why cut it out and then maybe have to put it back later when you rewire to some other vehicle? And there's no reason to remove it. It's not hurting anything, and it doesn't cause very much additional voltage drop, maybe 0.02 of a volt or thereabouts. So it's not a big deal. And people today, it's kind of funny. We can talk about this a little bit more if you wish, but they're just afraid to do anything. They're afraid to cut the cable off or shorten the cable up. They just wad it up like they do the coax and think everything is fine. By the way, that's not the proper way to install a radio in a cabin of a vehicle.
Well, speaking of that, we've talked about how important it is to actually not be afraid of drilling holes in our cars to mount our antennas. We've talked about how important it is to connect dedicated external, or I'll say external, but our own wiring to get power to our radios and not rely on wiring that comes in the vehicles. What is the third pet peeve or good advice that you have for our listeners who are trying to do mobile HF?
I have seen everything. I mentioned earlier about a 706 being mounted atop an airbag. Most people really realize how much force an airbag actually subjects the passenger and driver to. If they're on full force, they explode. They literally explode. The exploder, by the way, is sodium iodide in most cases. It is an explosive. It is a carcinogen and a lot of other things. And it does literally explode at about 200 milliseconds. That's about roughly 200 miles an hour from the time it's uninflated till it's fully inflated. And if you put your mobile radio head in the path of a airbag, that faceplate is going to do a face plant right in the middle of your forehead or on your face someplace. And I see it at all, period. Suction cups, I don't care what you use, vent clips, there's a whole bunch of other ways. The safest place to mount is below the center line of the dash, and in the center of the dash as close to the driver's side as you can get. And one of the easiest ways to do that, if you just cannot or will not drill holes in plastic and other mounting areas in the car, is to use a gooseneck mount. And they attach to the seat bolt. So you remove the seat bolt, you put this down, you screw it back down, and it is securely fastened and screwed and bolted on. Things like magnets, Velcro, double-sided sticky tape, wedged-in blocks of wood, you name it, will come loose in the event of a crash. Now, it's one thing perhaps to have a 4 or 5 ounce cell phone flying around inside your car. It's a whole new thing to have a 2-pound remote controlled head for your transceiver flying around, because it could kill you.
Well, that is definitely some good advice. We've seen some pretty terrible pictures of what some people have done to the insides of their cars as far as ham equipment go. And I know several people who don't have their heads attached to anything. They kind of let them just float around on the dash, as they're driving, and just grab them as they needed. So that is some really good advice. Now, there is actually a fourth topic that is one of the most interesting things I learned from your website that wasn't strictly applicable to mobile HF, but it's something that definitely improved my thinking about antenna performance. It definitely helped me understand the importance of having a good analyzer. And one of the things that I learned that I think is a common misconception with most hams from your website is that a low SWR or 1-to-1 SWR does not equal the optimal resonance point of the antenna. And on your website, you talk a lot about things to do feed line matching and whatnot, but could you talk about that a little bit? Because that's a lesson that I really want a lot of new hams to learn, is that SWR is not the only part of the picture.
That's true. Well, let me say first, if your antenna is unmatched, in other words, like a little short, stubby antenna mounted with a clip mount or magnet mount on your trunk, and it shows a low SWR, that just tells you that the antenna is lossy. Someplace that antenna is lossy. A good quality mobile antenna, properly mounted on a car, will have an input impedance of someplace around 25 ohms. Now, what that entails is not only the ground losses involved, but also any coil losses and conductor losses in the antenna, plus the radiation resistance, whatever that may be. Now, you can't, by the way, measure those separately. In other words, you can't measure ground loss with an antenna analyzer, SWR bridge, or however you do it. You can calculate them pretty close, but you can't actually physically measure them. So SWR really has no bearing on what the efficiency of the antenna is, only if your transceiver might be happy. And I say might be, because again, if you have an unmatched antenna that's 25 ohms, then the SWR that you would measure with an SWR bridge would be 2 to 1. But that's fine but if you tune the antenna a little bit, the SWR will go down. In other words, if you tune the radio up in frequency or make the antenna longer so that it's inductively reactive, the SWR will go down. So in fact, in the we're looking at, and we actually increase the length of the antenna slightly, the SWR will go down to about 1.5, 1.6 to 1. Keep your radio from being happy perhaps, but there's also about 35 or 40 ohms of reactance there, and we don't want that. Because what happens again, as I mentioned earlier, is it can cause an excessive amount of intermodulation distortion, which we don't want to do. So proper matching is important. And while we're on this subject, I mentioned earlier about doing proper common mode chokes, but we also have to do, if we're using a motorized antenna, have a proper choke on the motor leads. Now, one way to find out is that you can tune up the antenna. There's lots of on-site ways to do this. I explain online in my matching article how to do this with an antenna analyzer and to do it correctly and do it very quickly. An SWR bridge would take you several hours. You can do it in several minutes with an antenna analyzer. So if you follow all of these rules and you tune it all up and everybody is happy, then you'll end up with a low SWR that's across the bandwidth of the antenna. You will have less common mode if you tune it up properly, and your transceiver will be happy and you'll get full power out and you won't have any intermodulation distortion to speak of. So it's a combination thing, Jeremy. We have to do not just one thing or not just two things or three things, but all of the things to come down to the common denominator.
Well, folks, I specifically asked that question because I know a lot of that will be over the heads of new hams, but the point that I really wanted to drive home is that SWR is not the whole story. And a good antenna analyzer like a rig expert is just absolutely an invaluable tool to help you understand how your system is going to perform.
Yes, that it is. And I want to point out one more thing. A lot of people who use an antenna analyzer, and most particularly, say, a 259 or 269 MFJ, is that there's also an SWR readout. And they pay attention to it. Instead of following the reactance is when X equals 0, that's where the antenna is resident. Whatever the reactance happens to, or the resistance happens to be, is whatever it happens to be. But the issue is that if you want to tune up an antenna in a hurry with an antenna analyzer, particularly a 259 or 269 MFJ, is you take a piece of tape and you cover up the SWR readout where you can't see it. So, and I tell everybody, I even say online, because everybody seems to think that SWR is king, but it's not. It really just means that, well, let me give you an idea. Let's say the SWR is 2 to 1, just for sake of argument to pick one up. That could mean that the antenna has 25 ohms of impedance. It also might mean that the antenna has 100 ohms of impedance. And it also might mean that the antenna has a resistive value of 50 ohms, but has a reactive ohms of either plus or minus 35. So SWR doesn't tell us what we need to do if we're going to match an antenna. And it certainly is not a measure of antenna efficiency any more than a DX contact is.
Folks, we've been talking to Allan K0BG, the owner and operator of K0BG.com, the web's most thorough resource on mobile HF installation. We've covered just scratch the surface. Make sure you're drilling holes through your car to get the best possible metal contact with your antennas. Make sure you're running your own power leads. Don't put your faceplates or other radio components in places where you could get injured in the event that something happens. But we haven't at all talked about impedance matching or bonding, or about a million other subjects that we could spend time on. Allan, I really want to thank you very much for taking the time to speak to us. Any final thoughts before we part?
Well, my webpage and my email are out in the open. If anybody has a specific question about a specific item, they're free to email me. As I said, it's open on the front page of my webpage, and I do my best to answer all of the emails within 24 hours and typically half that amount of time. And typically I get anywhere from 3 or 4 a day to as many as 50. So it just depends on the time of year, but I do my best to answer them all.
Well, Allan, we certainly appreciate you coming on the Photime podcast to answer some of our questions. And so do you think you'll be at Dayton this year?
I will be at Dayton.
Well, then I look forward to meeting you in person. We're going to be wandering around the pavilion and the flea market and conducting on-the-spot interviews with folks to see what they think about Dayton this year. So hopefully we'll get a chance to meet in person. But again, I can't thank you enough for the work that you've done for the community and for spending time here with us today on the Photime podcast.
And I sure appreciate it, Jeremy. It's been my pleasure.
All right, folks, this has been KF7IJZ73. Back to you, Cal.
You know, not too bad for a guy who just moved halfway across the country, right? I'm talking about Jeremy. Man, thank you very much for putting that together. It was a tremendous call, and would love to have you and Allan back on the program again, because I think we're just getting out of the shallow end into the deep end with the call there, but a lot of great information. Again, Allan, his call is Kilo Zero Bravo Golf. You can find him online at KiloZeroBravoGolf.com. That's K0BG.com. And it's a massive website. It's the one website you go to when you ask someone on an internet forum how to do something regarding mobile amateur operations. It's there. If the question has been asked, it's been answered probably in triplicate on Allan's website. So I want to encourage you to go there. Again, Allan, thank you for coming on the program. Hope we can have you back really soon. And want to remind everyone, episode 25 is coming up. Again, it's going to be some giveaway stuff, and you want to make sure you check it out. Until then, check out mtcradio.com. They are the show sponsor, and we would love for you to give them your business. They're helping keep the program on the air. Don't forget, you can subscribe, you can like us, you can follow us, all those cool things, and it can all be done at itsphotime.com. I'm going to roll out, guys, but next time I'll be back with George and Nick, and we're going to have some really cool stuff coming up. It's going to be exciting. Till then, guys, 73.
Thanks for downloading, listening, and subscribing to AmateurRadio15.com presents Photime, the other ham radio podcast. You can find our past episodes, web links, and more at AmateurRadio15.com. That's AmateurRadio15.com. Follow us on Twitter at Photime Podcast, and remember to visit our show sponsor, Main Trading Company, at mtcradio.com. Till next time, 73s.